In both science fiction and real life, robots are usually metal machines. They've got lots of moving parts. There is another school of robotic design, though, advocating robots made of soft materials. Matthew Borgatti is the lead scientist at Super Releaser. We talked earlier, and I asked him to explain exactly what a soft robot is.
So a soft robot is not a super solid term. It's still a fairly young research field. But to get a gist of it, a hard robot is anything that's made of like steel and linkages and valves and things that are hard and there's no yield or giving to them. A soft robot, in contrast, is something that's made of elastomers, silicones, rubbers, works through pneumatics, works through essentially ways of getting it to move around that compensate for like the force of the world and reacts really dynamically. Instead of being like a walking leg, it's sort of a walking system.
And just describe what your soft robot does. It is able to move. How does it work?
Yeah. So the way this guy works is there are air channels inside of a seamless silicone skin. And the way that that works is each of the air channels is variegated. It's got a bunch of little pockets inside, ribs, that when it inflates because of pressure, it deforms in a predictable way. And so it's essentially, you've got two mirror sides, one that controls the left half of the body, one controls the right half. And since I can prototype and test and play with different ways of getting it to move, I eventually, rolled different versions of the robot until I got one that had a nice walking behavior.
Now, we know that fairly august institutions, including Harvard and MIT, are working on versions of their own of soft robots. What makes your design different?
Well, what I've been focusing on is how do you make a soft robot. Also, though many people have played with walking before, the focus for my research has been how do you reduce the complexity and how do you reduce the amount of effort required to make and iterate soft robots. So usually these prototypes are very expensive, they require a lot of hand labor and time. And since I specialize myself in manufacturing, I'm an industrial designer with an animatronics and special effects background, I thought I could reduce the amount of labor it took to make a soft robot and bring the technology fairly far, fairly fast if I was able to make them and play with them in really rapid fire iterations.
And the way that you're able to do that is by using 3D printing?
Yeah. So the process that I use is everything I have is in CAD. I'm modeling it on the computer, and then I slice it up into molds and I print out the molds. And since I'm using some pretty inexpensive home printers, I'm using, for my current generation of prototypes, I'm using this thing called a MakerBot. For the earlier generations, a friend of mine, a collaborator, Jim Brett, over at a company called Viridis, he gave me access to all this printing technology, and I could fire off a bunch of different molds all at the same time for a fairly low cost, cast them, and compare the performance of what I got out the other end.
You have also released this so that others can play with it and, as you say, try to improve upon it. Why did you choose that route? Why kind of release it to the public in this way?
Well, I'm hoping to achieve a couple of different things. One is I feel that there's a lot of potential to expand it into products, but there's nothing on the market at the moment. And the reason for this is probably that not enough people are playing with it. Oftentimes, when people have a problem and they know something exists that might be able to solve it, they start applying, experimenting. If a problem is present enough to be a market, people are going to be interested in it. But as it stands, the field hasn't really published accessible information. And so I thought, well, there are products that publish a recipe to get you inspired to use their product on the back. It's an invitation to play and to maybe incorporate like their product into your life. I was thinking, if I publish, more people learn about it, more people play with it, it might move the field forward and it might make the field valid for starting a profitable business based off of a specific product.
So let's talk about that. Do you have plans for some kind of profitable business out of this kind of technology?
Yeah, so I'm currently collaborating with a couple of different inventors and designers. Another advantage of being open is it's very sort of low-key to play with other designers, just be able to have an artist come in. There's no NDAs or patents to protect. Everything being published means it's a low barrier to entry. And since it's in common language, I have other people coming in and collaborating. One of them being a spacesuit designer named Kari Love, who's helping me design orthotic cuffs. So the idea is that people with cerebral palsy, people with a disability that they could use some robotic assistance with, say, moving their arms, that a one-size-fits-all mass-produced cuff like a tennis band might be able to give them a little bit of robotic assistance without being incredibly expensive or needing to be special fit to them by a prostheticist or a prosthetist or an orthopedic surgeon.
It sounds fascinating, Matt. We've got to leave it there. We look forward to knowing more about it as you go forward. Appreciate your time.
Thank you so much.
Matt Borgatti is lead scientist on Super Releaser.